Okay, chapter 7 starts with ratios and proportions, and most of us have a big background with ratios and proportions as it was taught a lot when you were in 5th, 6th, and 7th grade. So our goal today is just to make sure that we understand how to express ratios in simplest form, and there are some other forms that we'll talk about as well. A ratio is just a number in combination with another number as the quotient, where the first number is divided by the second, as long as s, the second number, is not 0. Take a second and just refresh yourselves by simplifying the following ratios. Here we should have had 3/5. Here we also should have had 3/5. Here we should have 4 over n, and in this example we should have n over 4. Take a second right now and answer questions 1 through 7 by simplifying each ratio and writing it in simplest form. So a proportion is simply two ratios that are equal, where A and B are the terms first and second in the first ratio. The third term of the proportion is letter C, and the fourth term is D. We can extend that out all the way as long as we know that the ratio of A to B, C to D, E to F, and so on are all congruent. So we can extend a proportion further than just two simplified ratios. Some proportions that exist in nature are the divine proportion. As you see, there's the golden ratio, which I will talk to you about tomorrow. The Fibonacci sequence is a series of numbers that has a ratio involved with it. One of the things that people used to think about was there was beauty in nature by finding patterns that had to do with certain proportions and ratios, the golden ratio being one of them and the Fibonacci sequence being another. Take a look at these flowers and how they might follow certain patterns. Pine cones follow the Fibonacci sequence. And so you have other examples of simple ratios in nature, and a lot of people believed, especially further back when math was just being discovered, that these ratios were part of beauty in the world. Take a second and finish numbers 8 through 12 by simplifying the ratio and writing it as a ratio with the same units. The next examples are actually starting with number 13 on the back of your worksheet, and it says that two complementary angles have measures in the ratio of 2 to 3. So if x was the factor by which we multiplied the ratios of 2 to 3 to get 90 degrees, we would ultimately get the answers of 36 and 54, because 3x plus 2x would equal 90 degrees, where x is the factor by which we multiply 2 and 3 together. This is question number 14 from your worksheet on the back. Take a second and try to answer question number 14, where the ratios of two supplementary angles have a ratio of 3 to 7. Your answer should be 54 and 126. And finally, this is number 15, where the ratio of a triangle has 2, 2, and 5. Remember, we can extend ratios out as far as we can as long as the sides or whatever are proportional. The answers you should have got for those three angles are 40, 40, and 100, where we obviously could then conclude that it would be an isosceles triangle. Take a second and answer questions 16 and 17 from your packet. In question number 16, with your equation of 2x plus 3x plus 4x plus 4x plus 5x equals the interior angle measures of a pentagon, we have to go back to the n minus 2 times 180 formula, and find out that the measure of the largest interior angle would be 5 times 16, which would get me 140 degrees. X would equal 16. Multiplying it by 5 as the factor would be 140 degrees. This is the question to number 17. Number 40, the perimeter of a triangle is 48 centimeters, and the lengths have a ratio of 3, 4, and 5. The lengths of each side are 12, 16, and 20. Take a second, finish your worksheet, and we will go over it in class tomorrow. Bring any questions you have as well.